Okay, so today's title is logs. And remember, we kind of already talked about this a little bit, but when you're finding a log, all you're actually doing is finding an exponent or finding the power. So if I'm asking you to find the log, okay, I'm really just asking you to find the power. And it's just a different word for it that you aren't really used to seeing. Okay, you did this in algebra too. It's just kind of an extension of that. So if I'm asking you, here's our first problem to actually take a look at. If I say log base 4 of 16, what I'm asking you is how do I get from 4 to 16? What exponent gets me from 4 to 16? 2. It's that simple. Okay? So now then what I want to show you is sometimes let's pretend like we didn't know. Okay? And remember me talking about just a second ago, to undo addition we subtract, right? And to undo multiplication we divide. So when you're looking at this, what goes with logs are exponents, which is what we studied Monday and Tuesday. And what happens is, and we call it circle math, okay? Put your pencil on the 4, go through the answer, and land on the 16, okay? So watch what that means. Where did we start our pencil at? We started it at the what? The 4, because the base of a log is the base of an exponential problem, okay? Bless you. Then we went through the x, and that's because the answer to a log is an exponent, right? We're looking for an exponent. So I was looking for the exponent, so there's my x. And the answer that follows the log is actually the answer to exponential, 16. Okay, now watch, I'll show you again. We started at 4, I wrote a 4. We did circle math, we went to the x is my exponent, and we landed on 16, and there's my answer. Okay, to undo logs, it turns exponential. Okay, that's an exponential problem, right? What's the answer? 2. But it just looks different, doesn't it? We're used to seeing this. But when you tell me the answer is 2, you've actually found that log base 4 of 16, right? How do I get from 4 to 16 with a 2? Those are the same things.
So you have to rewrite the whole thing?
No, you do not. It's just, you'll need to later. Okay, so you have to understand where it comes from. So the answer then to this is x equals 2. Okay, let's go to another one. These you can do in your head on purpose. Like I'm letting you be able, I'm doing easy problems on purpose to learn the concept, right? So log base 5 of 125. Okay, write yourself a little note here. What I'm asking you is what exponent to get from 5 to 125. I want to ask you that. That's what I'm saying to you. Guys, what gets me from 5 to 125? What is the answer to this? 3. Everybody agree? Okay, and then, but just to show you, let's say, okay, now write this for me. Let's say I have this and I'm saying, guys, I have no idea what this equals. I'm saying log base 5 of 125 equals what value, right? Okay, what you're doing in your head, if you want to show you the reverse of it, okay, the inverse, let's see if you can write it exponentially for me. What's the base of the exponent? Where do we start? 5. We go through the x, which is the answer of a log is the exponent. And the number that follows a log is the answer. So I'm saying to you, 5 to what power is 125? It's another way of looking at it, which is 3. Okay? Now let's go to another one. If I say log base 10 to 100, I'm asking you, how am I going to get from 10 to 100? How am I getting from 10 to 100? What works, guys? 2. Right, what exponent works? 2. Okay, but the answer is 2. But again, we're trying to practice circle math. So If I say, what is this answer? When I'm asking for a log, I'm asking for an exponent. What is the exponent to get from 10 to 100? You told me it was 2. Okay? Now, the other way to look at it, try to write it for me. Write this in exponential form. Where do I start? At the 10. The base of the log is the base of the exponent. We go through the x, which means, because that's the exponent. That's what I'm looking for. So there it is. And the answer to exponential follows a log.
No.
So what was the answer? 2. Okay? Alright, I'm gonna let you try 2 on your own. If I say log base 3 of 27, and then I'm gonna give you one more, log base 10 of 10,000. Okay, and if you have your exponents written from the other day, right? If you're thinking about this, I'm asking you 3 to what power gives me 27. I'm saying 3 to what power gives me 27. What's the answer?
3.
3. Good. Okay, and on the next one, I'm saying 10 to what power gives me 10,000. Guys, what's the rule there? Right, if I've got, I'm saying 10 to what power gives me 10,000. The exponent, remember, is however many zeros you need when you're doing base 10. Right, I need 4 zeros. So I need 10 to the 4th power, so x is 4. Okay, so that's kind of the basis of it, right? But now then, let's throw in a few things that make it a little more complicated, of course. Right, here's another one. This one says log base 2 of 2 to the 10th power equals x. This is the reason that I was showing you circle math, because sometimes they aren't quite as easy. Okay, I'm asking you, and some of you may see it right away, right? What I'm asking you here is what exponent gets me from 2 to 2 to the 10th? Does anybody just know?
No.
It's 10. What? Yeah, okay, now I'll show you what I mean. Right, I'm saying what gets me from 2, what exponent gets me from 2 to 2 to the 10th power to make them match? It's 10. Right?
I got it.
So, okay, so now if I'm gonna solve this, you're gonna do circle math for it, right? And some of you already see that the answer's 10. But if you do what I taught you, that's the reason I made you practice that. I'm saying 2 to what power gets me from 2 to 2 to the 10? A log is a power. What power, if you think about it, what power gets me from 2 to 2 to the 10th power? Well, 10. Okay, but if you don't see it and you look at it this way, what is x when the bases are the same? We learned this yesterday.
10.
10. Okay, now the next one. What if I said log base 2 of 2 to the 8th? Log base 2 of 2 to the 8th. Do you see the pattern? I'm asking you what exponent gets me from 2 to 2 to the 8th power. What exponent works there, guys?
8.
8. If you don't see it, that's why I taught you this. I'm saying base 2 of x equals 2 to the 8th. We've already learned that when the bases are the same, the exponents are equal, so x is 8. Here's another one, try it. Log base 10 of 10 to the 8th power. What exponent gets me from 10 to match 10 to the 8th power? 8. If you don't see it, again, x is 8 because the bases are the same. All right, so now that you understand that, we're going to throw a little wrench in it, of course. All right, and see if you can do this one. This one kind of gets a star. Log base 5 of 1 over 25. Think about what I taught you to do with this yesterday. That's what I would do first. Think about what I taught to you to do this yesterday. I'll give you a second to think about this. Jake. Okay, how did I tell you to rewrite that? 5 is -2. And then it makes this problem super easy. Well, it gets me from 5 to 5 to the -2, -2. Right, now then the next part is just a memory thing. Like, we've already studied this in the past, I'm trying to refresh your memory, right? So this is kind of just a big, huge think bubble. Think about this for a second. How can I rewrite the square root of 4 with an exponent? It's kind of weird. It's called power over root. So it's 4 to the 1/2. Okay? So what if I asked you to write the square root of 7 using an exponent? Remember, first of all, why do I even care about exponents? Why am I trying to turn numbers that aren't exponents into exponents? Why do I want the square root of 7 as an exponent? What are we studying? Logs. What's the inverse of logs? Exponents. Right? Exponents and logs go together. That's what a log is, isn't it? A log is an exponent. So if I've got the square root of 7 and I'm trying to deal with exponents, there's no exponent there. Well, make one. Okay? So what is the square root of 7 using an exponent? Because we're talking about logs, we need exponents. 7 to the what? 1/2. And they call this, and you can write it really neat right here for me, power. The top number is the power, and the bottom number is the root. And let me explain what that means for a second. Okay? Look at the number 7. What's the power of a 7 when there's nothing written there? 1, Miss H. Good job, guys. Okay, it's a 1. Okay? And then the root is a 2. Well, isn't square root? That's what a square root is. So that's the reason that they put the square root under here. Okay? So what if I asked you for the cube root of 7? The cube root of 7, what is it going to be? Yeah, good job. Not 1/2, 1/3. So this is 7 to the 1/3 power. Because it's power, because there's imaginary power written right there of a 1, and the root is a cube root, power over root. Let's try the next one. What if I say the 5th root of 8? How to write that using exponents? Why do we need exponents, right? Jake. So this would be the same as 8 to the 1/5 power. Right? Okay, another one. What about this one? What's that going to be? 7 to the 1/6. All right, so you kind of got it, right? Okay, the only one I haven't done, and that's it. Okay, so let's try them. Here's another example. Log base 5 of the cube root of 5. Okay, here's the issue. When I'm asking for a log, I'm trying to get you from 5 to the cube root of 5. When I'm asking for a log, I'm asking for an exponent. Well, there is no exponent there. But can I write the cube root of 5 again pretty with an exponent?
Yes.
Yeah, it's no different than what we did here with this 125 right here. 1 over 25 we rewrote as 5 to the -2 because we needed an exponent. You can't find a log without an exponent. So then that's what this is here. You can't find a log, by hand. Your calculator can find a log later. I'll show you how. Okay, so then this is the same as log base 5, and we're going to write this as 5 to the 1/3. Right? So what's the answer to that? 1/3. Okay, here's another one. Try this. Log base 3 of 2 to the 3rd power. This looks too funny, doesn't it? It doesn't work. I don't know how to get from 3 to the square root of 3. right? So I'm gonna rewrite this using a power so that I can look at it and see. So log base 3, the 3 to the 1/2. So the answer is what? Okay. Now we're gonna switch gears again. It's something called a natural log. And it's a log with a base of e. Okay, you guys ever heard of pi? Obviously, yes, right? What is pi related back to? Circles, right? You can find the area and you can find the circumference of a circle if you know the radius and pi, right? That's because every single circle, okay, the number 3 is related to every single circle, isn't it? Right? Somebody discovered that using the number about 3, right, and the radius can come up with the area, or 3, and the radius can come up with the circumference. Now, e, okay, is another really famous number that's actually used more in real life than even pi. Okay, it's used to find interest rates. Okay, it's used to find growth and decay of a substance. Right, if you have a radioactive substance and you want to know how long before the radioactive substance is safe to be in the area, they're using E. Okay, if you want to find out, you know, how your money's going to grow so that you can retire at 50 instead of 80, okay, they use E. That's what E is for. So E actually has a value, and its value is approximately 2.718, or 2.7, basically. Okay? And in all the problems that we've studied so far, right, we have these kind of random bases. And the reason we're using these, like base 4, base 5, right, base 10, base 3, the reason is because I'm trying to show you the properties of a log. But in real life, the log that's used the most is a log with a base of E. Okay? So when you have a log base E, it's kind of like saying I've got a log with a base of 2.7. That's what that means. Approximately 2.7, right? And what happens is it occurs so much in science all the time, okay, that they don't call it that anymore. It's got its own name. It's so common, almost like pi. Pi has its own day, right? Okay, well, because it's so important. Well, same with E. E is so important that they don't even call it this anymore. They just give it LN. A cursive L, a cursive L, and an N. And guys, that's the same thing as saying log base E. These are the same thing. So when you see an LN, right, if you just want to put a little E right there to make you feel better, you can. It just means a log with a base of E. In other words, instead of the base being 3 or 5 or 2, it's 2.7. All right? So let me show you what that means. And it's actually very easy once you see it. So I'm going to say I've got a natural log, and then this is what they're going to write. Looks kind of weird, doesn't it? Right. So I'm asking, a log is asking for an exponent, correct? Well, what is the base? What have I taught you already? What's the base of a natural log? Yeah, it's E, isn't it? 2.7. So let's put ourselves a little E here. So I'm asking you, what exponent gets me from E to E squared? 2. It's that easy. Okay, if you don't see it, let's do our little thing here with the X. We're going to use circle math because I'm looking for an exponent. The base is E. I'm looking for the exponent, and it equals the number that follows the log. This whole thing right here. So what is X? 2. Let's try another one. So when you see ln, this is just a log with a base of what, guys? E, okay. You don't have to write it if you don't want to. I'm going to ask you for this one. What's wrong with the square root of E? Does it have a power?
Yes.
Right. Does this have an exponent? I asked the wrong question. Good job. Does E have an exponent as it's written? No, can we rewrite the square root of e with an exponent so that we can find a log?
Yeah.
Yeah, a log is an exponent, so if it doesn't have one, we need to create one. So ln e to the what? 1/2. Okay, when you see ln, it just means the base, instead of being 4, or 5, or 10, the base is e. What gets me from e to the 1/2 power? 1/2. If you don't see it again, I'll show you. E to the x equals e to the 1/2. The bases are the same, so x is 1/2. Okay, here's a weird one. It's actually so easy, but it looks weird. Solve that for me. It's 1. Okay, it's 1. The natural log of e is 1. And this is the reason. There's a base right here of e, correct? What is the exponent of a plain old e? A plain old anything, but if it's not written, what's the exponent? 1. So how do I get from e to e to the 1? 1. So the value of the natural log of e, by the way, guys, is just 1. All right. Here's a different kind. Solve for x. But this is kind of different because even though it's in log form, there's a log, there's the base, right? I'm going to put an x right here instead of an answer. And I'm going to tell you the exponent. So what's the base of this log, guys? 10. What's the exponent of this log? Right? The answer to a log is the exponent. So watch, circle math here. 10 to the 3rd power equals x. So I'm telling you 10, right? I know the exponent. The answer to a log is the exponent. It's 3 equals x. Well, what is 10 cubed? That's a 1 with how many zeros? 3. So x is 1,000. Notice that, guys, in this problem, okay, the missing part was this. It wasn't the base. I had the base. It wasn't the exponent. I had the exponent. This technically is just an exponential problem, but you had to understand to turn it that way. Okay? Think of another one like that. What if I gave you log base 6 of x equals 2? Don't say it out loud. Let everybody give themselves a shot. I'm looking for x, and x this time is here. It's not on the end like it's been in all the other problems. So what do you think the answer is? 36. Because I know the base of the exponent. I know the exponent already. It's 2. Well, what is 6 squared, guys? And it equals x. So 36. Good job. Okay, so now's where your calculators are going to be needed. If you don't have one, it's okay, but it would help for here because the numbers are not going to be as pretty. So log base 10 of x equals 0.4. The numbers aren't as pretty. Do I know the base? Yes. Do I know the exponent? Yes. So type that in your calculator. 10 to the 0.4 power. What is x going to be? Yeah, 2.51. We'll round to the nearest hundredth. How about that? Okay, now the next one. The natural log of x equals 1.5. I'll give you a second to think about that one. Okay, do I know the base? What's the base? What? E. Do I know the exponent? Heck yeah, I know the answer. If you know the answer to a log, you know the exponent. That's what a log is. The log is an exponent. So here's my log, and here's my answer. So 1.5 is the exponent. And where did I land? Back here at the answer. So this time I'm looking for x in a weird spot, right? Did you know your calculator has an E on it? Okay, if you don't know that, then come here, turn your calculator on, and let me show you the E. There's a couple different places. If you look above the division key, there's a little bitty blue E. You can use that. Above the division key is a little bitty blue E. But also diagonal to the 4, which if you'll notice it says ln, the natural log, right? And above the natural log in blue is an e to the x. Does everybody see it?
Yes.
Okay, so what I'm gonna do with this is I want e to the 1.5 power. So I'm personally gonna just use this one. So second ln, and I'm talking about 1.5. What my calculator is actually doing, you guys, is it's taking about, well, it's gonna use the whole thing, but 2.7 to the 1.5 power. That's what my calculator is doing. Kind of like using the pi key on your calculator. Right, you know how sometimes you use the pi key instead of 3.14? That's the same thing. We're using the e key instead of 2.7. Okay, and we're gonna hit enter. So x is 4.48.
What would you rather us use?
The e. The e to the x, not 2.7. Use the actual e key. That way your answer is more accurate. Okay, the next one. Okay, another one that's weird, so let's give it a shot. But if you'll just keep the same concept going, you'll be fine. Okay, once again, I'm missing x, and x is not at the end of the problem, which means I know the exponent. What's the base, guys?
E
So I know e
squared.
squared, excellent, I heard it, equals all of this mess right here. Okay, well, write it down. X squared minus 1. Now, kids get confused because they think that this is a variable. It's not. It's a number. So in your calculator, find me 2.7 squared, or e squared.
7.39.
Okay, so 7.39 equals x squared minus 1. How am I going to solve for x squared? What am I going to do first?
Add.
Yeah, add the 1, move the 1 over. So now I'm at 8.39 equals x squared.
Square root.
Good. How to get x all by itself? What are you supposed to do? Take the square root of both sides. So in your calculator, take the square root of 8.39. It's actually a positive or negative, but yeah, 2.9, because it's squared, right? For you. Okay, we have one last problem on our notes. Log base 5 of log base 3 of x equals 0. I know it looks messy. Just do what I've taught you, though. Do what I've taught you. You know the base, you know the exponent. Do what I've taught. The answer to a log is an exponent. Do I have the answer to that log? Absolutely. So what's the exponent here, guys? Yeah, the exponent. I get where you're going. What's the exponent?
0.
0. So I know this. I know 5 to the 0 power equals all of this. Very good. And what does anything to the 0 power equal? 1. Look at you guys go. Okay, now this is in a weird form because the equal sign is on the left. Where's the equal sign always been?
Right.
On the right.
It doesn't matter.
Okay, but it's the same thing. So if you really don't like it that way, then you can rewrite it like this if you prefer. Okay, but it's the same. What's the base of this? 3. What's the answer to the log? 1, which is the exponent, and it lands, it just goes the other way.
X.
If you don't like it, rewrite it. Put the equal sign on the right side and do the same thing. So what does x equal, guys? 3. Okay, and we're done with the notes.
Yeah.